Hello everybody. I would like to introduce this presentation. This is a special presentation. It is a short quiz, and among the solving of this quiz together, we will review some concepts and some formulas regarding the two-way ANOVA test. The design we will explore is the 2x3 factorial ANOVA design, which means that we have two factors. The first factor, number of levels for the first factor is 2, while the number of level for the second factor is 3. Here the question. We have below the two-way ANOVA table, which is partially filled with the calculated values in some cells, and we have some missing values in other cells. So for alpha, which is equal to 0.05, which is the significant level, what is needed? First, we need to fill in the blanks, or we need to replace the question marks by the correct values. We have another short questions. How many rows level were used in this experiment? How many experimental units, or sometimes it's called the subjects in this experiment? D, if you know that the total observation, which is the summation of x, is equal to 1322, what is the value of the correction factor? The other question, what is the value of the summation of the squared of the observations? Summation of x squared. And finally, which is the important, is regarding the what conclusion can you draw? So these are the question we need to solve for it. But before starting the solution, let's understand the two-way ANOVA table. Regarding the two-way ANOVA table, we know that we have the sources of the variation, one for the first factor, which is called the row factor, and the other is the column factor, and we have an interaction between the two factors, and we have the error, and we have the total. What is missing here? For the degree of freedom, we need to calculate for the degree of freedom for the second factor. From now on, I will call the row factor as factor number 1 and the column factor as factor number 2. And we need to calculate the degree of freedom for the interaction and the degree of freedom for the error. Regarding the sum of squares, SS, the SS for the first row is missing, and the total SS again is missing. Regarding the mean square, MS, the MS for the first factor is missing, and the MS for the interaction is missing. Regarding the F statistic, both for the second factor and the interaction are missing. And regarding the F critical, it is needed to determine the value of the F critical for the first row and the value for the second row, while for the interaction, it is simply known. So how to start? Let's understand the first factor row. This is the first factor. The degree of freedom for this factor is known, while the SS for this factor is missing and the MS is missing, while the value of the F statistic is known. And notice that the MS for the error is already known. So by using the formula to calculate the value of F for any factor, simply we should divide the mean square of that factor by the mean square of the error. So the value of F for the first row is known, it is 1.90, while the mean square for this factor is missing, and the mean square for the error is known, it is 186.89 inside the table. So if we rearrange this formula to solve for the MS for the row, which is the missing value, we say that the MS for the row is simply equal to the value of the F for that factor multiplied by the mean square of the error. This is the value of the F statistic for the first factor, it's 1.90, and this is the MS for the error, 186.89. So simply we can get the value of the mean square for the row, or the mean square for the first factor, 355.09. So this is the calculated value for the mean square. Again, regarding the first factor, we know the degree of freedom for this factor, but the value of the SS is missing, while the value of the mean square has been determined. So using the formula to calculate for the mean square for any factor is simply by dividing the value of the SS for that factor by the degree of freedom for that factor. So the MS for the first factor, now it is known. The value of the SS for the row is missing, and the value of the degree of freedom for this factor is already known. So if you rearrange this formula to solve for the SS for the row, simply we multiply the mean square for this factor, multiply by the degree of freedom for this factor. This is the MS for the first factor, the row, and this is the degree of freedom for this factor, it's 1. So this is the value of the sum of squares for the first factor, which is the row. So this is the value for the SS for the first factor. By using the same former formula, and for the other factor, the second factor, which is the column, the degree of freedom is missing, the value of the SS is known, and the value of the mean square, MS, is known. So again, this is the formula to get the ms for any factor. So ms for the second factor is simply equal to the ss for this factor divided by the degree of freedom of this factor. The ms for the column is known, it is 13.73. The value of the ss for this factor, again, it is known, it is 27.45, while the missing value is the degree of freedom. If we rearrange this formula to solve for the degree of freedom for the second factor, simply we divide the ss by the mean square. The ss for the second factor is known, and the mean square for that factor is already known. So the value of the degree of freedom for the second factor is simply equal to 2. So we replace question mark by this value, which is 2. And again, for the second factor, the degree of freedom is known, the SS is known, the MS is known, but the value of the statistic F is missing. But notice that the value of the mean square for the error is already known, it is 186.89. So we know the formula to calculate for the value of f. The value of f for any factor is simply dividing the mean square of that factor by the mean square of the error. The value of the f statistics for the second factor is missing, while both the mean square and the mean square of the error is already known. So we simply can substitute. This is the ms for the second factor, and this is the ms for the error. So the value of the statistic f is 0.07. Notice that the value of the f for the second factor is somehow it is small, so the chance to reject the null hypothesis is very small. So we replace the value of the f in the ANOVA table. Regarding the error, the degree of freedom for the error is missing, while the value of the SS is known, and the value of the mean square is already known. So we can take benefits from the formula of calculating the ms for the error. We say that the ms for the error is simply equal to the ss for the error dividing by the degree of freedom for the error. The value of the ms for the error is the missing one. The value of the ss for the error is known, and the degree of freedom for the error, the value of the degree of freedom is the missing one. Sorry, this is the missing one. But for the ms or the error, it is already known. So we have this formula with one missing value. So if you rearrange this formula to solve for the degree of freedom for the error, we simply divide the SS for the error by the mean square of the error. This is the SS for the error, and this is the MS for the error. So the value of the degree of freedom for the error is 12. Now, if you check the column related to the degree of freedom, the df for the first factor is known, for the second is known, for the interaction is missing, for the error is known, and the total is known. So you know the formula how to calculate for the total degree of freedom by summing up all the degrees of freedom of the rests. So the df total is known, the df for the row is known, for the column is known, for the interaction it is missing, and for the error it is again known. So if you keep the degree of freedom of the interaction in one side and move all the variables to the opposite side, so you should change the sign from positive to negative. So this is how to calculate for the df of the interaction, df total minus the df for the first factor minus the df for the second minus the df for the error. This is the total df. This is the df for the first factor, this is for the second, and this is for the error. So the value of the degree of freedom for the interaction between the two factors is equal to 2. Now we need to solve for the rest of the cells which contain question marks. What to do now? Regarding the interaction, we know the degree of freedom for the interaction. And we know the SS for the interaction, but the value of the mean square for the interaction is missing. So you know how to solve for the mean square for the interaction simply by dividing the SS of the interaction by the degree of freedom for the interaction. The mean square is missing, the SS is known, and the df is already known. So this is the SS for the interaction, and this is the degree of freedom for the interaction. So the final value of the mean square for the interaction is equal to 939.39. Again, for the interaction, now the value of the mean square for the interaction is known, but the value of f is missing. And notice that the mean square of the error is well known, so we can use the formula of the calculation of f by dividing the mean square of the interaction by the mean square of the error. This value, the value of f for the interaction, is the missing one. The mean square is known, and the ms of the error is known. So we can simply substitute. So this is the ms for the interaction, and this is the ms for the error, and this is the final value of the f for the interaction. Now we have 3 missings. If you check for the column of the sum of squares, the SS for the first factor is known, for the second is known, for the interaction is known, and for the error is known, but for the total it is missing. So you know how to calculate the SS total by summing up all of these SS. So this is the SS for the row first factor, this is for the second factor, this is for the interaction, and this is for the error, and this is the value of the SS total, 4,503.98. Now the missings is only the F critical for both the first factor and the second factor. And we know how to determine the value of the F critical for any factor. We should know first the value of the probability, which is the area right to the value of the F critical, which is the same as the significant level, which is equal to 0.05. It is given in our question. And again, in order to get the value of the F critical, we need to know 2 degrees of freedom. The first one is called the degree of freedom in the enumerator, which is actually the degree of freedom for the first factor. It is 1. And regarding the second value of the degree of freedom, which is called the degree of freedom in the denominator, it is simply the value of the degree of freedom for the error, and it is already known, it's 12. So you should know all of these 3 values: the probability, the first degree of freedom, which is the degree of freedom for the factor, and the second value is the degree of freedom for the error. So you can simply return back to one of the F distribution table for probability of 0.05. In this row, we should have the first value of the degree of freedom, which is the degree of freedom for the first factor, which we are interested in, and the second value of the degree of freedom is the degree of freedom for the error, which is 12. So the intersection between these two values of the degrees of freedom is simply the value of the F critical, which is 4.75. So the value of F for the first factor at probability 0.05 and first degree of freedom 1 and the second of 12 is equal to 4.75. So this is the F critical for the first factor. The last missing is the F critical for the second factor. With the same method, same technique, we should know the probability. It is already known and given. And regarding the first degree of freedom, it is the degree of freedom of the second factor, which is equal to 2. And regarding the second degree of freedom, it is fixed. It is the degree of freedom for the error, which is 12. So with the same method, this is the degree of freedom for the second factor, 2, and this is the degree of freedom for the error, which is 12. So the intersection is equal to 3.89. So the value of the F for 0.05 and degree of freedom 2 and 12 is 3.89. So by this, all of the needed records have been calculated and filled inside the two-way ANOVA table as we see here.
خلصت؟
لا شوية.
يعني خلصت حكي؟
لا ما خلصش حكي. حكي بخلصش.
بدي أعمل سندويشات أجيب لك إياهم وأنت
لا
بتسجل؟
سوي لي بس أخلص أنا بجي باخذها.
ما
خلص جي.
سخنتهم عشان
تسخني ليش تبعتي خلص.
شاي.
خلص بنسخن الشاي. بدي ربع ساعة بس بالكتير. Now let's solve together these simple questions. How many rows level were used in this experiment? how many levels for the first factor. You know how to calculate for the degree of freedom for any factor. You simply use this formula. The degree of freedom for the first factor is simply the number of first factor level minus 1. The df for the rows is known, it is 1. The number of rows level is missing, it is needed, minus 1. So we have one missing value in this formula. So if you move the minus 1 to the opposite side, so you should change the sign. So the number of rows level, it is simply the value of the degree of freedom for this factor plus 1. So this is the degree of freedom for the first factor. It's already 1 plus 1, it's equal to 2. Can you think of other way to get the value of the first factor levels? If you take care of the title of this presentation at the starting, you can answer this question very simple. How many experimental units or subjects in this experiment? The total number of the observations. You remember how to calculate for the total degree of freedom. You use this formula. The degree of freedom total, it is simply equal to the total observation, capital N, which is same as the experimental units or experimental subjects, minus 1. The degree of freedom total is known, while the missing is the value of N. So if you solve for N, so N it is equal to the degree of freedom total plus 1. So we have capital N equal to 17 plus 1, which is equal to 18. Do you think that we have another way or another method to find or to calculate the value of the experimental units? Consider that the design of this ANOVA or two-way ANOVA is balanced design. Actually, I talked in a previous presentation for the two-way ANOVA for the balanced design. And balanced design is simply means that the experimental units or subjects inside each groups are the same. We calculate the number for the number of levels for the first factor, it is 2. And regarding the second factor, how many levels we have in factor 2? If you know that its degree of freedom is simply 2, You should add 1 simply to the 2, so the total is equal to 3. And again, if you recall the title of the presentation, you can solve for this question. So we have 2 factors. The first one is the row with 2 levels. This is for level 1 and this is for level 2. And regarding the second factor, which is the column, we have 3 levels for this factor. So you can make these arrangements. This is the first level for the second factor, and this is the second one, and this is the third one. So we have a total of 6 groups. And for the balanced design or two-way ANOVA balanced design, the number of the subjects inside each of these 6 groups should be the same. So now you can simply count for the number of subjects in each of these 6 groups. Simply we have 18 subjects. We need to distribute these 18 subjects equally in each of these 6 groups. So 18, if you divide 18 by 6, so you will get 3 subjects. So here we have 3 subjects or 3 observations. Here we have 3, and here we have 3, and also for the rest of the groups the same. So if you sum all of these, you will get a total of 18 experimental units. This is another question. If you know that the total observation, which is the summation of the X or the observations, equal to 1322, what is the value of the correction factor? You remember the formula to calculate for the correction factor? The correction factor is simply equal to the summation of the total observation, which is simply summation of X squared divided by capital N, which is the number of the experimental units or subjects. So the correction factor is missing. The summation of X is known. We should square it. And the value of the capital N is already known in the previous slide. So this is the summation of the observations. We square it and divide it by 18, which is the number of the experimental units. So if you proceed, you will get the value of the correction factor. what is the value of the summation of x squared? Summation of x squared is simply the summation of the squared total squared observations. So you know the formula to calculate for the SS total. SS total is simply equal to the summation of the squared value of the observation minus the correction factor. The SS total, it's known in this table. This is the needed value, and the correction factor has been calculated in the previous slide. So if you solve for the summation of x squared, move the correction factor to the opposite side, so it's equal to the SS total plus the correction factor. This is the SS total, and this is the calculated correction factor, and this is the summation of x squared. Finally, we need to draw conclusions regarding the first factor. The value of the F statistics is 1.90, while for the F critical it is 4.75. So as the value of the F statistics is less than the F critical, we accept the null hypothesis for the first row. And the null hypothesis for the first row states that the means of the first factor are equals. And actually we have, how many means we have? We have 2. So for the first factor, the first mean is the same as the second mean. Regarding the second factor, which is the column, again the value of the calculated F is 0.07, and it is significantly less than the value of the F critical. So again, for the second factor, because the F statistics is less than the F critical, we accept the null hypothesis. And the null hypothesis for the second factor states that the means for the levels of this factor are the same. So we count for the number of levels. We add 1 to the degree of freedom, so we have 3. So for the second factor, the first mean is the same as the second mean, is the same as the third mean. And regarding the interaction, see here the value of the F statistic is greater than the value of the F critical. So in this case, for the interaction, we reject the null hypothesis and accept the alternative one. And the alternative hypothesis for the interaction is always states that there is an interaction. So we have an interaction. So as you see here, for the first 2 factors, there is no significance, while for the interaction we have a significance at level 0.05 or at confidence level of 95%. So for the row, the value of the F statistics is less than the critical one. so we accept the null hypothesis. For the second factor, again the F statistic is less than the F critical, so again we accept the null hypothesis. While for the interaction, the value of the F statistics is greater than the F critical, so we reject the null hypothesis and accept the alternative one, which states that there is an interaction between the two factors. Another way to understand these conclusions is by exploring these figures. What we have here, we have the F distribution curve for the first factor, which is for 2 degrees of freedom, which are 1 and 12. So for the degrees of freedom 1 and 12, this is the shape of the F curve. And regarding the calculated value of F, it is simply 1.90. It lies here. And the value of the F critical is equal to 4.75. So the value of the calculated F is less than the critical one, so we accept the null hypothesis. Another way to understand this conclusion is simply by understanding what's called the probability, the P. In some ANOVA table, there is no mention to the value of the F critical, but we have for the probability B. And the probability B is simply means, for example, for the first factor, the value of the calculated F is 1.90. So if you check for the probability for this value, and the probability for the F equal 1.90 is simply, in this graph, it is simply the area right to this value. And as you see here, the area right to the calculated F is greater than the value of the significant level, which is 0.05. So this is another way how to make a conclusion without the calculation of the F critical. Another way to make a conclusion is that this value of the F critical divide the region of this curve into 2 regions. To the right, we should reject the null hypothesis if the calculated value is lying inside this region, while to the left we should accept the null hypothesis. So because the calculated value of F lies in the acception of the null hypothesis, so we should accept the null hypothesis for the first factor. So for the first factor, we don't have any significance. For the second factor, this is the F curve for the second factor. It is not the same shape as the previous one for the first one, because it is drawn for other 2 degrees of freedom, which is 2 and 12. So the shape will differ from the previous one. And regarding to the calculated value of f, it is here, it is 0.07, while the value of the f critical, it is 3.89. So as the f critical is greater than the f calculated, we accept the null hypothesis. And if you check for the probability, the probability for f equal to 0.07 is simply the total area here, right to this value, and it is simply greater than 0.05, which is the significant level. And again, the calculated value of f lies in the non-rejection region, so we don't have a significance. And finally, for the interaction, this is the curve of the interaction. It is the same as the previous f curve, because it is for degrees of freedom 2 and 12. But the calculated value for the interaction is greater than the critical one. So we reject the null hypothesis and accept the alternative one. And if you try to find the value of the probability, which is simply the area right to the calculated value, it's clear that it is less than 0.05. Sometimes it is written like 0.000 up to 3 digits, for example. So because the value of the probability is less than the value of the significant level, we reject the null hypothesis and accept the alternative one. And again, because the f calculated lies inside the rejection of the null hypothesis, we reject the null hypothesis. So this is the conclusion for the interaction. We have a significance for the interaction between the two factors. That's all for this quiz and for this reviews of some concepts for the two-way ANOVA and review of the formulas used for the calculation of the two-way ANOVA table. Thank you and goodbye.